Welcome again to Virtual Science 2021. We're going to continue our adventure as we look at how matter is classified and identifying things. Now, these drawings at the top of the page I have today, okay, are the kind of things that they use to test your understanding of the material we cover. So each of these individual little dots, whether they're the open, the clear ones, or the dark ones, they represent atoms. So they ask you to look at these different pictures and decide which one in the picture represents a pure element, which one in the picture represents two elements, which one in the picture represents a pure element and a compound, which picture represents a mixture of two compounds, and which picture represents the mixture of a compound and an element. Pause the video and try and answer these yourselves right now. The kind of thing you're going to have to do when we test. If you try it right now, you're not being tested, so you get them wrong. When we go over it, you'll be able to see and learn. Okay, well, you should have answered these yourselves while you had the video paused. Okay, the first one says represents a pure element. Well, we know that it has to be the same and it has to be single atoms. So, number 4, all of the atoms look the same and they're not attached to any other atoms. Which picture represents a mixture of two elements. So we want to look for the picture that has single atoms, not joined together, but they're not all the same. So that looks like it would be picture number 2. Okay. Picture number 2, we have the clear ones, we have the solid ones. They're not connected to anything else, so they're elements, and there's 2 of them, so it's not pure. The next question says, which picture represents a pure compound? Well, a compound is 2 or more elements joined together. If it's pure, all of the compounds should be the same. Except picture number 1. We see this clear, dark, clear, clear, dark, clear, clear, dark, clear. These are compounds. They're 2 or more elements joined together. They're all the same in the picture, so it's pure. 2 or more atoms are joined together. All are clear. Solid, clear. Next one says, which picture represents a mixture of 2 compounds? That's picture number 5. Okay, we have the compound dark, clear, dark. And then we have this one's clear, solid, clear. So these are compounds, but they're not all the same. So they're a mixture. 2 compounds. One kind of compound is solid, clear, solid. The other kind is clear, solid, clear. And the last question says, which picture represents a mixture of a compound and an element? Well, these are single elements. They're single atoms. This is a compound. It's 2 or more atoms. We have a clear and a solid. So that would be number 3. Okay. Single clear is an element, and the compound is the solid clear. Okay. This is a review, so I'd like you to pause the video again and see if you can fill in most of the blanks on this page by yourself. Okay, hopefully you did take a look at this and try to fill in most of this yourself. We'll go over it, and don't worry while you're doing this in the process of learning if you make mistakes. Okay? We learn when we make some mistakes too. If we ever made a mistake, we'd still be living in caves. It's only by the process of trial and error. Okay? So we know that matter can either be an element, it can be a compound, it can be a mixture. If it's a pure substance, okay, it can be an element when all of the atoms are the same, or a compound, and elements combine in a fixed ratio. So like this compound is always 2 solids in a clear, and here's another one that's like the same ratio, 2 solids in a clear. Atoms of an element is atoms of the same type and are found on the periodic table, and they can be a pure substance. Compounds, and this should be a review, is two or more atoms combined, and they're always in a fixed ratio. Compounds can be pure substances. Like we said before, compound like water can be pure. Compound like salt can be pure. Okay. Now, let's ask us about mixtures. There's two big groups of mixtures. There's homogeneous mixtures, which are even, okay, are the same all the way through, and that's what the prefix homo means. Or heterogeneous, and they're not even. They're not the same all the way through. That's what the prefix hetero means. Okay. Special kind of mixtures. There are three types of mixtures. There are solutions, colloids, and suspension. All mixtures, whether they're homogeneous, heterogeneous, whether they're solids, liquids, gases, colloids, suspensions, solutions, whatever, doesn't matter. All of them can be separated by physical means. I put up here just to remind us, solutions are homogeneous. Okay. Colloids and suspensions are heterogeneous. Okay. Physical means there's no new substance, like those kids getting the iron out of the sand with a magnet. They did. It was iron in the sand, and it was iron when it was separated. It was sand when it was mixed, and it was sand when it was separated. So there's no new substance. There's no chemical reaction. If it's a solution on the video where the guy passed the light through the clear solution, okay, light just shoot right through it. Solutions are mixed evenly throughout, like Kool-Aid or salt water or sugar water. When you mix it up, it's the same. It means they're the same throughout. Solutions never settle or separate. So like when we looked at the salad dressing yesterday, it was a suspension because it's separated parts of the solution. The solvent is the part of the solution that does the dissolving. So sometimes if you have like gold thinner, it's called a solvent. Or if you use nail polish remover, it's a solvent because it dissolves. It does the dissolving, like of the fingernails or the paint. Okay. Part of the solution that gets dissolved, like if you put salt into water, the salt would be the solute, and the part of the solution that does the dissolving, in the example of salt water, would be the water, because the salt is going to dissolve into the solvent. Now we have some properties in math, and basically they're broken up, physical and chemical. Okay. First one we're going to start off with is physical properties. It says it's a characteristic of matter which can be observed, so we can just look at it, or measure. So like if I say the room is 12 feet long, that's a physical property of the room. And I might not be able to say just by looking and observing like, oh, I know it's 12 feet long, but I can measure it. Or like if somebody measures your height, they can get out a tape measure or a ruler or yardstick, whatever. And they measure you and say you're 5.5 inches, 5 feet, 6 inches tall. Okay? So it's something that can be measured. Okay? Examples of physical properties are things like the color, the shape, the size, the way it smells, melting point, the iron that those kids separated, is it magnetic? These physical properties can be used to separate mixtures. Okay, separating mixtures is something that people do. Okay, we want things. When you go to the grocery store and you get salt, you want pure salt. You don't want it the way they found it out in nature. Okay, when you go get distilled water, water for drinking, you want pure. So people are constantly separating stuff. Okay, so they use these physical properties in the real world to make the stuff that we use. Okay, now these properties that we're talking about here, Don't get confused, kids. These are not the only physical properties there are. Pretty much if a word is an adjective, right? Adjectives describe persons, places, or things. Okay, so if it describes a thing, that means it's a physical property because it's something we can observe. So, you know, it's thick or rough or, you know, there's just too many of them to list. So I'm not going to put every adjective we can think of in the notes. That'd be crazy. Okay. Some of the special ones that we talk about in this class: mass, which is the amount of matter in an object. We've already talked about volume. Volume is the amount of space an object takes up. We did some calculations on density already. It was the amount of mass in a certain amount of space. Okay, so the formula for density is just that: density equals the mass, the amount of mass in a given volume. So it's the mass divided by the volume. Solubility, we've been talking about solutions. Okay, so solubility is how much of a substance will dissolve at a given temperature. So you could measure the solubility of salt in water. You could just keep adding the salt to the water until no more dissolved and it started settling to the bottom. Another important physical property of matter is conductivity, whether or not heat or electricity will flow through the material. So some things like wires in your house, they're good conductors. The heat and electricity will flow through them easily. Things we call insulators, the heat and electricity will not flow through them. That's why a pair of pliers, for example, has both. The pliers themselves, the metal, electricity will flow through them, so they coat the handles with rubber, which is an insulator, and the electricity won't flow through the rubber. So if you're working with wires or something, you happen to grab one that has electricity in it, and you electrocute yourself. Physical change. So these things, these are properties. Properties can change. Okay, so that can change the color or something. We can paint the room, we can paint the walls, but there's not going to be a new substance. The paint is still paint. The wall is still wall. Okay, we could change the mass of something. Okay, we can cut it in half. We have two pieces with half the mass instead of the whole mass. Okay, we can change the volume of something. We have a liter of Coke. You can pour it in a cup. You change the size and the shape of the Coke, but there's no new substance. You still have Coke in a glass and Coke in the bottle. Okay, you tear a piece of paper in half. Change the size of the paper. You got two of those pieces. Okay? There's no physical change. Okay, you just pour it in half. Okay, we say that doesn't change the identity of the matter. So things tearing, cutting, melting, okay, all these ing words, okay, are changes. So that's one of the ways you can tell if something is a property or a change. Okay, a property is an adjective. Changes are verbs, they're ings. Okay, now the other group of properties are chemical properties. And they're characteristics that indicate if a substance will change or react to make a new substance. Okay. Unlike these physical properties that we can observe or measure, these have to be tested for. Okay, so like if you just look at something, you can't tell if it will burn. Okay, so like wood, we know will burn, but then there's like those tiles that you see at Lowe's that look like wood, but you wouldn't know if they don't burn unless you test them. Okay, so a lot of times, especially other things, you can't tell if they're going to react. Will this react with acid or not? It has to be tested for. You can't tell just by looking at it. Okay. Some of the chemical properties are flammability, whether or not it'll burn, or combustibility. Those two mean the same thing. Whether it will dissolve in acid, whether it's reactive with other substances. Okay. If there's a chemical change, okay, It's when one substance changes into another substance. We say for a chemical change, it has to create a new substance. So like the wood, if you burn the wood, it makes a new substance. You got the ashes. So you got the wood, now you got ashes. There was a bunch of smoke, and there's some water vapor that came out of the wood. All of those are different than the original wood was. Sometimes chemical changes are indicated by a change in temperature. Okay, and that's actually a big one. All the time, there's a change in temperature when there's a chemical change. Things get hot or cold, like the wood, or when you digest food, that's a chemical change. Okay, and you get warm, or it might change smell, or it might form gas or bubbles. So, like when you put hydrogen peroxide on the cup, that's a chemical change. It bubbles and it actually gets hot and it burns the germs. Okay. Chemical changes can be used to separate compounds. A lot of times in nature, people find compounds and they dig up iron out of the ground, for example. It's not pure iron and ready to use to make cars. You have to separate out the rust and get the oxygen off of it and separate it and break it up into pure elements so that we can use it. Okay. Burning wood, digesting, cooking, all of those things are examples of chemical changes. The Earth goes through both physical and chemical changes when it weathers. Earth's surface involves both physical and chemical change. So when rocks, it's physical when rocks split apart and streams weather thing and then it erodes. Okay, so the water keeps running over the rocks. Okay, and it breaks it up and it makes sand, but it hasn't. That's a physical change. The sand is made out of the same stuff as the rock is. It just got broke. Sometimes water freeze in a crack in a rock or a sidewalk during the winter, and when it freezes, it expands and cracks the rock. So it's just a physical change. You still have rock. You just got two pieces now. Okay. Chemical changes are like an acid rain, changes limestone. It causes it to deteriorate. And this happens to statues and buildings as well. Okay. We can use both physical and chemical properties to identify unknown substances. Okay. The police do this a lot in forensics. Okay, so if they find something and they're not sure what it is, they'll go test it in the lab and make sure you know what stuff is. Okay, so there's this example. It's solid, it's shiny, it's yellow, it's dense, it won't burn, and it's a metal. What is it? Well, it's gold. Okay, so we use these properties. Okay, this one's a chemical property. These other ones are physical properties. And we will is. Whether something goes through a physical change or a chemical change, we don't destroy atoms. And that's called the law of conservation. It means whatever we had before is equal in mass to whatever we have after. So even if we take something like burning that wall, we found the mass of the ashes, the mass of all the smoke particles. We caught everything. So we captured the smoke particles, all the water vapor, everything. The mass of all of those atoms would be the same as the mass of the wood before we burn it. Obviously, if we tear a piece of paper in half, the mass doesn't change. So the law of conservation says is the mass of all the substance present before a chemical reaction equals the mass of all the substances after the change. The mass is not lost or gained. Mass is not created or destroyed, but it can change form. So like the wood can change form, it can go through the burning process and it becomes ashes and it becomes the smoke particles. And atoms don't go away. Stop for our lesson today, and I hope everybody is doing well at home, and we'll see you next time.